Hey, it's Miss Miles here. Today's lesson will be on graphing. So we'll get right to it. If you are on your home page, and I'm sure that you've probably already clicked on to Unit 1, Scientific Method, um, through your Canvas course. So if you will look at your home page, we are on day 4. There is a Bozeman Science graphing video here, and you need to watch that because that will definitely explain a lot about graphing. We do have an assignment 1.05 graphing, and if you'll go ahead and click on that, you can pull that up. Today we do have a Pearson assignment as well. Remember, whenever you click on Pearson, and it will give the description there of what you're going to be completing. Whenever you click on Pearson, it's going to take you to your class link. When it takes you to your class link, all you have to do is find your Pearson Realize icon there on ClassLink. Click on that. You have an account. It will log you in on your Pearson Realize today. You are going through the processes of science and engineering design, and you're also completing a quiz. Typically, you have 2 to 3 assignments anytime there's a Pearson Realize assignment. This is really comparing scientific method, which we talked about in the previous day, to the engineering design process. So what you're going to be doing is just following your instructions. Remember, the drop down box here will tell you what to do. And then in the bottom right corner, you'll have the ability to advance to the next page once you're done completing what the previous one has asked you to do. On this particular one, I think this is a really cool picture right here. This is an anglerfish. It says these predatory fish are found in the deep ocean in an area where there is very little, if any, sunlight present. Use curiosity, skepticism, open mindedness, and creativity to come up with 2 to 3 questions about this fish that could be answered through the use of scientific inquiry. I mean, I have a lot of questions about this fish. How does it live in an area that has very little light? It itself probably doesn't need light. I mean, we're not plants. But if when we get to ecology, we'll talk about food chains and food webs. And so you should understand that even though, you may be an organism that where you're not eating plants directly, you do depend on plants in some part of your diet. You're either eating plants or you're eating things that have eaten plants. So plants depend on sunlight. So sunlight really runs every food chain and food web here on Earth. So this anglerfish living in an area, where there's no light at the depths of the ocean. How does it get its food? What food does it eat? What lives down there that it can actually eat? What are all those bristles on the body of the fish? So there's lots of different questions that you can ask there, and it wants you to come up with 2 or 3 questions about that fish. Remember, when we're doing scientific method, asking questions, that's a big part of it, and asking good questions. This next thing is talking about what we talked about on the previous day. This is looking at well, it's got a mouse here, but there was an icon on the previous day. I didn't really go over it, but this was something that people used to think, which was just a crazy thought, I guess. It says place a dirty shirt or some rags in an open pot or barrel containing a few grains of wheat or some wheat bran, and in 21 days mice will appear. There will be both males and females present, and they will be capable of mating and reproducing more mice. We know that mice are attracted to maybe an area where they have a good food source. So, like the wheat, the grains of wheat there would be a food source for them. So they might be attracted to that area. Um, some people used to believe that maybe the dirty shirts and dirty rags would actually just make the mice. So that's that whole thought of spontaneous generation that Francisco Reidy's experiment sort of did away with. The maggots trying to get to the decayed meat. the decayed meat did not produce the maggots. So that's what that's asking right here. That did the dirty shirts actually produce the mice, or did the mice, produce other mice? And then it will go through this chart here. Reading and interpreting graphs is a very good skill to have. You can click on your instructions there and go through the different icons. And you're looking at yearly cigarette use in the United States, which thankfully has, definitely decreased. I think people are getting wiser about the harmful effects of cigarette use. And then it's going to ask you too about how scientific experiments and scientific data will then influence policies. After we learn that cigarette smoke is definitely detrimental to your health, how that maybe led to warnings on cigarette packets and things like that. And then this is just going through and comparing scientific inquiry to engineering design. And it's wanting you to go through that whole process. And then you have a couple of questions here to answer. Remember, once you get finished with that interactivity, you're going to click in that check mark in the top right hand corner. And if you don't see check marks here on each one of these, that means you've missed something. You didn't do everything that it asked you to do. So I can see right here on page 1, I haven't completed that. So I'm going to click back onto page 1 and make sure that I'm going and I'm clicking on everything that it's asking me to click on. And then once you're finished with that, at the top, you should also have a quiz that you'll need to complete. And so that should be your Pearson Realize for the day. But if you will go to your graphing assignment and pull that up, we'll get into graphing now. So 1.05 graphing is your assignment. If you click on that, that's going to pull that up in a Kami document or a Kami assignment. And so you should just be able to graph directly on to your page today, right onto the computer screen. So that's a pretty good aspect of using Kami. Remember, there are all these different tools that you can use here on Kami. You can definitely use your text box. You have the ability to draw. And then you also have the ability to do different shapes. I would suggest today that if you're needing to do a shape, that if you're needing to draw a line or if you're needing to draw a box, that you click on the shapes icon, and then you can draw that very, very easily on Kami. But I'll go to my other document, and it will just show your assignment, but just a bigger view of it. So we're going to talk real briefly about graphing, and then you're going to watch Bozeman Science, and he'll go into more detail about graphing. Then you need to complete your graphing assignment and also your Pearson Realize today. I'm just going to start highlighting a few things. Of course, we have different types of graphs. Today you will have a pie chart to create. Also, you'll have a couple of bar graphs and then also a couple of line graphs. You'll have 5 different graphs that you're going to create today. When you're looking at a graph, you have to make sure that you include a title. A title summarizes information that is included in the graph. A title gives you lots of good information. Sometimes on tests like the ACT, you can really get a lot of science questions correct just by looking at graphs and looking at the title of those graphs. Remember independent variable. That's the thing that I change or the thing that I am testing. So it's very important that you understand the independent variable typically goes on your x-axis. So that's your horizontal axis at the bottom of your graph. Your dependent variable is typically on your y-axis. Your dependent variable is your data. And it says it is the result of what happens as time, dates, depth, and temperature are changed. I did want to tell you also up here on independent variable on the x-axis, time is typically on the x-axis. Now, not always, but a majority of the time will be on the x-axis as your independent variable. So sometimes time is changing, and then you're seeing the result of something else. As it goes through changes over time. Um, there are, of course, experiments where time is your dependent variable. One that I like to do in class is the Alka-Seltzer lab, where we take pieces of Alka-Seltzer, which is an older type of medicine, and we're going to see in what temperature of water the Alka-Seltzer will dissolve the fastest. So in that case, our independent variable becomes the temperature of the water, and our dependent variable becomes the time. So time is not always your independent variable, but most of the time, time will go on the x-axis. And then you have to look at the scales for each variable. You have to figure out maybe your highest data point and then your lowest data point, and then look and see how much room you have on your graph to figure out what your scales or your intervals will be for each one of these graphs. So we'll get to our graphing, but I just wanted to highlight those things that are listed there on your assignment. So this first thing you need to make sure that you take note of is what type of graph. So graph A is going to be a bar graph. So bar graphs, typically, you're going to show a bar for each different thing, and a bar graph is different from a histogram. But typically your bars don't touch necessarily. I don't know if anyone would take off points though if the bars didn't end up touching on these graphs that you create. But try to just keep with that whole thought that bar graphs are separated from each other. Graph B will be a line graph. So when you have a line graph, you're going to plot data points, and then you're going to connect a line to show, causation between those two. Graph C is a bar graph as well. Graph D is a line graph. And then your last graph, graph E, is a pie graph or a pie chart, which we will get to in just a few minutes. So we're going to go back and start with graph A. The first thing that you need to start when you start on a graph is you need to look at your data. So over here, we have our data, and we're going to try to represent that on a graph. So what you have here, you have the months of the year, and then you have the number of deer. Typically, your title will represent both your independent variable and your dependent variable. So, a simple little title here, you could come up with a fancier title, but your title probably just needs to be like number of deer per month is what we're going to be graphing here. So our number of deer per month is what we probably need to have as our title. So number of deer per month. So when you come up with a title, and if you don't do a title on each one of these, you're going to lose points. So make sure you always include a title. And it's going to ask you again at the bottom of the page. Number 3 says, what is an appropriate title? Label above the graph in the box provided. So if you forget, once you start your questions, it's going to ask you and remind you, hey, did you put a title on this particular graph? So this is number of deer per month. Now, here's the way we need to start graphing. It asks down here, what is our independent variable and what is our dependent variable? I'll let you fill that in just a second. But typically, like I said earlier, time goes on the x-axis. So over here, we are going to label the x-axis with the word month. So we're going to go through and label that month. So label your x-axis month. Over here on our y-axis, this is our vertical y-axis. We are going to label that with the number of deer. So you guys can do a neat little text box there. as you're going through. I could do a text box, but I'm just not. I'm just going through and writing that. But please use your text box so yours is all nice and neat. When you're using Cami as well, you can go through. We have to come up with our numbers and our lettering, and you can go through. If it's on the x-axis, you can just use one big text box and just space that out. But on the y-axis, you'll probably have to use one text box per increment there. So here's what we need to do. I would suggest, and you can't really space out the months evenly. You could do January here, or you could skip a line. I'm probably going to skip a line, but you're going to go through January, February. You're going to write a letter there for each one of those. And I could probably go and do that in the text box, and it'll probably look a little bit better. So why don't I get a text box going on that? And I'm just going to lower the size of that text box, and maybe it will match what I'm going to say here. So we're going January, we're going February, March. I might need a little bit smaller here. But we're going to put those letters in between the lines because we're going to do a bar graph. So I'm doing January, February, March, April. We have May, June, and I think I've gotten off a little bit. I probably need to space that a little bit better. Let me lower that so it's not so big. Okay, so that might be better for our spacing. Okay, so we have January, February, March, April, May, June probably needs to come back a little bit. Then we have July. Then we have August. Let me space that on out. August, September, October, November, and then December. So we have all the months of the year. And if this were, a bigger graph, we could probably put one of these bars between each one of these. But I understand that this is January, this is February, and I'm sure you could space yours out a little bit better to look a little bit better than mine. My spacing is not all that great there. But let me just fix that a little bit. Okay, so we have all of the months represented, and you could do a text box to, write out the word January, February, but, since we have this labeled month, we can figure out what these months of the year are. So here's what we're going to do. We're going to start looking at our numbers. If you look at your numbers over here, and I'll just change my color real quick, our highest number here is 38. And our lowest number here is we have a couple of tens. So what you need to do is look at, your numbers, your data, and then also look at your the number of lines that you have in your data table. So we need to make it up to 38. That's our highest number. So if we look over here, I'm going to count the number of lines. We have 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We have 20 lines. So what that tells me, we have to get up to 38. So let's just think about 40. If I took 40 as just an estimation of our highest number and divided that by the number of lines that we have, which is 20, so 40 divided by 20, I'm going to get 2. So that's going to let me know that I probably need to go by increments of 2. If I went by increments of 2, then that probably will be good enough to accommodate every part of my graph. So, and then each one of these, then I'm going to 2, 4, 6, 8, 10, 12, 14, all the way up to 40. Each one of these lines is going to represent increments of 2. Now, you may not have room to put a number at each one of those, but you have to make sure you leave room for each one of those. So 2, 4, 6, 8, 10. I'm going to go ahead and mark where the 10 is. just so I know. So 10 is at this one. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I'm going to put the 20 right there. So even though I'm not typing in or labeling every number, I'm still leaving room for that number. And so when I go to graph, then I will know what each one of these increments represents. So then we're still counting by twos: 22, 24, 26, 28. There's 30. I will type in 30. So then we've got 32, 34, 36, 38, and then there is 40 at the top. So we don't actually need the 40, but we do need the 38. So I'll put that 38 in there. Now, notice I took, my highest number, I rounded it up because it was easier to divide 40. And then I divided 40 by 20. That was the number of lines. And that gave me 2. So I knew that I had enough room to count by twos on this particular graph. So now all we have to do is start graphing. So on each one of these, we're going to be doing a bar. So as you're doing a bar, so we know that this one is January, and I can scoot that over just a little bit so it looks a little bit better. Once I scoot one, they all kind of scoot over, but I think that's pretty good. So January is this area right here where I'm going to do this bar. I can go up here to my data and see in January, the number of deer was 15. Okay. So as I go up, I'm going to start counting. This is 2, 4, 6, 8, 10, right? 12, 14, 16. I don't have a 15, but I know between 14 and 16 is 15, right? So I am going to do a line right there, and then I'm going to draw my bar. Now, probably for you guys, the best way to do that is to do use your shapes on canvas and then just put in a bar up to that height, right? So that's a pretty good looking bar there. It might need to be lower just a little bit here, just down just a tad. And that is the bar for January. Now, really, your bars are not supposed to touch, but it's sort of hard to do that. So February is the next one. So on February, 2, 4, 6, 8, 10, 12. For February, I'm going up to the 12 because I can look over here and see February, the number of deer was 12. So I'm going to draw a line right there. Go again to your drawing. You can do a box. You can do a different color if you would like to do a different color. And I'm going to put a bar right there for February. So once you're finished with this, all of your bars might be different colors. They might be the same color, but they just need to be represented on your graph. I'm going to go ahead over here and do September. Remember, September is where we had the most deer. Maybe this was an apple orchard and, the fall, all the apples were falling from the trees, and maybe we just had a plethora of deer because it was fall in the apple orchard. So during September, we had more deer than any, and it went all the way up to 38. So as you go through, you can just graph and do a bar graph for each one of those. Of course, I didn't complete March, April, May, June, July. I didn't complete these months through there, but you're going to have a bar for each one of these. And so that's the way you're going to do your bar graph. So that's a pretty easy way to do a bar graph, I think. Now, once you get finished with your bar graph and you've completed all of these bars, it's going to ask you, what is the independent variable? Remember, your independent variable is on your x-axis. So your independent variable here is the month, or you could say time. if you wanted to say time. That is your independent variable. So your x-axis right here is where your independent variable is. What is your dependent variable? Well, your dependent variable is here on your y-axis. So in this case, the dependent variable is the number of deer. Okay, so your dependent variable is always on your y, and then your independent variable is on your x. Okie doke. So you will complete the rest of this bar graph. Let's go on to our line graph. Now, this one wants you to do a title. I'm not sure if yours has a box, but remember, each of these graphs needs to have a box at the top. So what I would do on this one, you need to look over here, number of days, number of bacteria, and then your title is really just the combination of those. Number of bacteria over days is probably what I would say, because we're using 6 days there and we're trying to see the number of bacteria. Now we will get to bacteria later on, but you will see that bacteria have what we would call exponential growth. And so as bacteria grow, one becomes two, two becomes four, four becomes eight, eight becomes 16. They grow exponentially. And so we'll be able to see that on this chart. So as we're going through, we're going to label our x-axis. So our x-axis is right here. And remember, time is typically on your x-axis. So we're going to put number of days right there. That also, and let's just make sure we move that correctly. That's also going to be our independent variable. Remember, our independent variable is our x-axis. So we can type in number of days right there as well. So this is our label for our graph, and then this is us answering the question. Our dependent variable, we're looking at the number of bacteria. So that's our dependent variable. So time has gone forward, and we're counting the number of bacteria every day they're growing. So our independent variable there, number of bacteria. Ooh, and maybe if I spelled bacteria correctly, that would be a lot better. Okie doke. And then an appropriate title. We've already put the title up there, but we said number of bacteria over days, or you could say over time. So now let's look at our increments. Let's look and see what we should do as far as labeling. Now, if you look at the number of days down here, I have a low number, sorry, a number of days down here. I have 1 through 6. So really, I have so much room here for days. So I think it's best on this one just to space this out as much as possible, just because we have the room. So I'm going to put 1, and then I'm going to count 1, 2, 3 bars, and then I'm going to put the second day. So we're just going to space this out just because we have room to do so. So 1, 2, 3. Let's see, I want 1, 2, 3, and then 1, 2, 3, and then 1, 2, 3. And this, we just don't have a lot of days down here, so we're just going to try to space those out as much as we can. 1, 2, 3. And you could do it a little different than this, but the thing is you need to try to use as much of your graph as you can. So there's our number of days. We just had 6 days. Now, over here on our y-axis, we're going to look at our number of bacteria. We have to get all the way up to 200. That was our highest number of bacteria. So remember, we have 20 lines. So 200 divided by 20, we are going by increments of 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I'm going to type in 100 right there. When you are doing your numbering, you need to have at least 2 numbers written to the side. So people reading your graph will know what your increments are. So as we go on up, 110, 120, 130, 140, 150, 160, 170, 180, 190, and at the very top up there, 200. So at the very top, I'm going to put in 200 just so I can remember that and know that the very top is 200. So I have three numbers over here. As long as you have two, then that's probably good enough. So as we go through, we're going to do a line graph on this one. So this involves plotting points, okay? So on day one, and we could space that and have the day right on the line. That's probably a better thing to do. So let's scoot that just over and have it directly on a line. So on day one here, okay, is everybody kind of on a line? Yeah, I think it's good. So on day one, we had 4 bacteria. So what we're going to do, where these two numbers meet, 1 and then 4. What did I do? 2. Oh, this is not 2. That's 20. Sorry. I goofed up. 20, 20, 40, 60. No, I went by 10. Sorry, I messed myself up. I didn't go by 2s. I went by 10s. Messing myself up. Okay, sorry. Change that. Let me put it in the right color. Okay. Ooh, I messed myself up. That was a 10, not a 2. Okay. So that's a 10. So right here, the day one, we have 4 bacteria. Okay, so we're going to put a dot then. And it's hard to determine, but let's see, 5 would be about halfway. So we're going to put a dot about right there. On day 2, we had 16 bacteria. So 10, 20. It's probably close to about right there. On day 3, we had 40 bacteria. So 10, 20, 30, 40. On day 3, we had 40 bacteria. On day 4, we had 80 bacteria. So remember 10, 20, 30, 40, 50, 60, 70, 80. Right there, we're going to put a dot. And then on day 5, we had 100 bacteria. We're going to put a dot right there. And then on day 6, we had 200 all the way at the top. This is classic exponential growth. Now, what you're going to do then, since you're doing a line graph, and I'll just try to show you a line graph as small as possible, just so I don't mess up my dots here. But you're basically going to be connecting these dots and doing just how the general growth is going. And this is how the general growth is going. Close. I've messed up just a little bit right there. But this is called exponential growth. So what ends up happening, the human population is actually right now in exponential growth. When I was born, our population was about 3.7, 3.8 billion, and now we're getting very close to 8 billion. So human population is in exponential growth. What ends up happening when you have organisms in exponential growth, eventually this bacteria, they'll run out of something. They'll run out of food, they'll run out of oxygen, they'll run out of space. And then eventually you'll have this dramatic die off where eventually, they will die off. But that's why bacterial infections are so bad in humans and why you have to have antibiotics to defeat them, because you don't just have one bacteria, you have a bunch of bacteria and they grow and they produce rather rapidly. So when you have a bacterial infection, you have to take some sort of antibiotic to kill them off. And eventually, your body might fight them off on their own. Like you raise your body temperature so it gets too hot in your body for the bacteria to survive. But sometimes, the consequences of that causes damage to the body. So that's why bacterial infections are really bad, because they grow exponentially. So hopefully that will help you get started on a bar graph. That will help you get started on a line graph. The next one, graph C, is a bar graph. So you guys can think about your increments. I would probably go by 5s right here. 5, 10, 15, 20, and you should be able to get that. And then hours of study on your X, and then you can just space those out however you would like to at the bottom. Here on temperature and enzyme activity, temperature is going to be on your x-axis. That's your independent variable. You change temperature, and then you can determine enzyme activity. So enzyme activity will be over here. So it should end up being a graph, and do not copy this because I haven't done anything. But you'll be able to see a graph that looks something like this. It'll look something like that shape. And what ends up happening, you'll have an optimum temperature here for enzymes. So enzyme activity will increase until it reaches its optimum temperature, and then it'll start getting too hot and it'll decline. And enzymes do what we call denature. They start to break down. And then the very last graph that you have is a circle graph. So the thing I want to tell you about a circle graph, of course, you're going to have to remember to do your title on each one of these graphs, right? So the thing I want to tell you about a circle graph is that you need to do a point right in the middle. So we need to do a point right in the middle. And you need to also remember when you're talking about increments, when we're talking about something like, for example, oh, this is not a straight line. Let me go back and draw a straight line because that is not straight at all. So when we have a pie chart, and let me just draw a straight line right here. I'm not saying that you're going to have these numbers, but let me just remind you, half over here would be 50%, right? So this is 50%. This is also 50%, but I'm going to divide it further. So let's look over here. I'm going to do a line. Well, maybe that wasn't exactly in the center. So if I divide that into fourths, or I divide this 50% by half, I'm going to make these quadrants. This is 25%, and then this one is also 25%. Okay, so that's just a reminder with pie charts, not that these percentages are these. I'm just showing you or reminding you of your percentages in pie charts. Now, here's what you have to do over here to get your percentages. These are favorite games and the votes. So you've surveyed some people, and they voted for their favorite game. So what you need to do is total this up right here. How many people are we talking about? How many people did we survey? So let's count them up real quick. 3 plus 7 is 10. Plus 2 plus 5 is 17. Plus 3, that is 20. So we surveyed 20 people, right? To get our percentage over here, we are going to have to divide. So you're going to say 3 divided by 20, right? 3 divided by 20, and then you're going to say equals, and then you're going to multiply that by 100 to get your percentage. So in your calculator, if you do 3 divided by 20 equals times 100, you see that that is actually 15%. So you're going to go through and you're going to have to calculate the percentage on each one of these. Then you're going to have to figure out, look at all your percentages and do a pie chart to show me those percentages. I would like you to do a key. So whatever color you end up coloring Call of Duty, you can write Call of Duty in that color. So let's say you do Call of Duty in blue. So you're going to write Call of Duty in your key over here. And then you're going to shade whatever part of the graph that is to represent 15%. Okay, so let's say that this is 25%. I would say 15%. Let's just do a line here. 15% would probably be maybe about that much, right? And so then you could color all of this, and we'll just do a big coloring area. Then you could color all of this, that 15%. And you can probably do a much better job than what I'm doing right now. But you can color that piece of the pie Call of Duty, and you can have that represent 15%. So go through, do your calculations. You have to divide the number of votes by the total, push equals times 100, and that's going to give you your percentage. Don't forget to do your title, and then all of those games should be represented then on your pie chart. So that was graphing. You need to go ahead now and go to Bozeman Science. This is the beginner's guide to graphing data, and he's going to help you a little bit further with graphs. And then once you're finished with that, you need to go and complete this graphing assignment. And then do not forget to do your Pearson assignment. Okay, so that's it. Let's go do some biology. Bye, guys.